Hey guys, so I'm going to be talking about the circulatory system. Hope you guys enjoy. Pressure regulation is so important, and what are the implications of lower or higher than normal pressure? As you can see in this graph, credits to American Heart Association for this, the normal pressure is less than 120, but if it's also lesser than 90 millimeters or defined as a low blood pressure, and if it's higher than 130, a clear indication that you have a high blood pressure. And so as you can see here, these are numbers that indicate 1 being the lowest blood pressure and 10 being the highest blood pressure. I did not order these specifically from 1 to 10 since all have really high blood pressure when blood enters. It's very, very high in these types of areas. Large and medium artery are called elastic arteries. They contain a protein called elastin, which helps convert them into elastic energy. And these are the reasons why I label them 10 to 9 because it's really strong within these parts. And so then it goes into the small artery, where small artery has vasoconstriction, which increases resistance, very smooth muscles in the cell wall of the artery, and then it goes into the arteriole. The conversion from artery to the arteriole is a great drop in blood pressure, considered the smallest branch in the arterial circulation. And so it moves on, and then as you can see, these are the toe cells, like just assuming that the toe cells have already arrived over here, and then that's when it's gained what it needs, for example, like glucose or oxygen, and then it dumps out all its waste, like carbon dioxide waste. It goes into the venule, which as you can see, it's starting to decrease. The blood pressure is really starting to decrease. The veins particularly, as you can see, these are the lines, presents the valves, because these valves, particularly the one located on our legs, prevent blood from flowing backward, and it keeps it flowing in only one direction, as you can see in this arrow. And the superior or inferior, they are what brings back the blood back to the heart, and which is why they have the lowest blood pressure. The following hormones that play in blood pressure. ADH was already given by Miss, so I'm not going to be explaining that. I'm going to be moving on to angiotensin. Please pause if you need to understand what I've been writing, but the liver produces first angiotensinogen, which then is catalyzed by renin, and it converts to angiotensin 1, which doesn't really play a big part, and then it converts to angiotensin 2, which causes a lot of things in the blood pressure. This stimulates adrenal cortex to release aldosterone. It stimulates a thirst center in the brain, causing us to want to drink or be thirsty, and it results to increase in muscle contraction, increase in blood pressure, and increase in blood volume. Moving on to aldosterone, which is the next hormone I'm going to be talking about. You could pause if you ever need to really read this out specifically. Aldosterone increases blood pressure in responding to a decrease in pressure. It targets specifically the kidneys, and it promotes sodium reabsorption, promotes potassium secretion, increases the volume, and it also increases blood pressure. Hormone which also increases the blood pressure, which is epinephrine, called adrenaline, a hormone that is secreted mainly by the medulla of the adrenal glands, and that functions primarily to increase cardiac output and to raise glucose levels and blood pressure. ADH, angiotensin, aldosterone, and epinephrine, they are what increase blood pressure. But there is one hormone that decreases blood pressure, and this is the atrial natriuretic peptide. Natriuretic peptide stimulates atrial myocytes, secrete atrial natriuretic peptide, and which can cause decrease in blood pressure, or the release of renin, which produce angiotensin 2. Equation P is the change of P. So as you can see here, 95 minus 5, and it will equal to 90. And the unit for this is millimeters of mercury. And then Q is for the blood flow. But let's just imagine it's 5 liters. And if you know the volume per heartbeat, or how much blood is present and how much beats per minute, you can plug it in over here. And then the resistance equation is 1 to the radius of 4. R is radius, not resistance. Let's remember that. We look for the resistance because that's what we really are looking for, which will equal to... It is very important to know what the blood flow is, what the heartbeat per minute is, what the diameter for it is, so that you can solve for any of these, whether it's a blood flow, resistance, or the change of P. That's how they really are all affecting each other.